this example, we have the cosine x divided by 1 plus sine x on the left-hand side and 1 minus sine x divided by cosine x on the right-hand side. It looks equivalent both ways. Both of them look complicated. So it's up to us which way that we're gonna use to start with. So typically we use the left-hand side. This time, let's pick the right-hand side to work on. The right-hand side expression is 1 minus sine x all divided by cosine x. And we're going to work top down. We're going to work toward to the expression on the left-hand side, which the top has one single term, but the bottom has two terms. So with this way, let's start with making the denominator to have the term of 1 plus sine x. So I'm going to copy the original one. And then multiply both top and bottom by 1 plus sine x. When you multiply the bottom, you multiply the top with the same expression. Because we're going to work toward to the expression that has denominator in the terms of 1 plus sine x. So after we multiply, let's see what we can do with the numerator, which is the product of 1 minus sine x and 1 plus sine x, all divided by cosine x times the quantity 1 plus sine x. The numerator product, recall the property that when you have x minus y times x plus y, this is the product of the sum and the difference. The result will be x squared minus y squared. So we're going to use this property to get the value of get the expression, the simplified expression of the numerator. Now we have 1 square, which is 1 minus sine squared, which is from sine times sine, divided by cosine x times the quantity 1 plus sine x. Keep in mind, we're gonna keep 1 plus sine x. So we do not distribute the cosine x in there. We keep it, but we're gonna work on the rest of the terms. As you see, or you recall the trig identity, the cosine square x plus sine square x equals 1. That means when you have 1 minus sine square x, or you subtract both sides by sine square x, which is equivalent to cosine square x. Now we're going to use it for this step. Since I do not have enough room, I'm going to go toward to the right here. So the numerator now, it can be replaced with the term cosine square x. Since the top is cosine squared, we can reduce with the bottom term and then leave one factor at the top of the cosine x for us. So we have the cosine x left over divided by 1 plus sine x, which is the same as the expression on the left hand side, and we are done. Exactly the same problem. If we handle it different way, cosine x divided by 1 plus sine x equals 1 minus sine x divided by cosine x. This time it will work by starting with the left-hand side expression cosine x over 1 plus sine x. And then we're going to work toward to the quantity or the expression on the right-hand side that has the numerator has 1 minus sine x. Copy it down, cosine x over 1 plus sine x. And to make the numerator has that expression, we're going to multiply the top by 1 minus sine x. When you multiply the top by 1 minus sine x, you would do the same for the denominator. And then let's see what we can do for the denominator. So cosine x multiplied by 1 minus sine x, all divided by the product of 1 plus sine x and 1 minus sine x, and use the property that x plus y times x minus y equals x squared minus y squared. Therefore, the product of the denominator there will become 1 minus sine square x, where the numerator remains as a product because we want to keep 1 minus sine x on the top part. And again, 1 minus sine square x is the same as cosine square x. So we can reduce the cosine x and cosine x on the bottom. That gives us 1 minus sine x divided by cosine x, which is the same as the right-hand side expression. So we are done showing or proving this identity.